Hi everyone, welcome to today's tutorial. So in this tutorial, we are going to discuss how we can work out questions concerning sets, and to be specific, interval notation sets. Alright, so if you have not yet subscribed to the channel, click on the subscription button and the notification button so that you don't miss out the videos that I'm going to be posting. And if you have any questions in math, physics or chemistry, you can simply just contact me using any of these lines on the screen. Both lines are on WhatsApp. You can send your questions there and I'll be able to help you. Okay, so if you have if you need tuitions or help in math, these are the same lines that you can contact me on. Alright, so let's quickly get into business. So the question is, let x be equal to 0, 10. So before I even start explaining this, let me first explain what it means if you have these kinds of brackets and then also these brackets. So the first set of brackets are called open brackets. So these are called open brackets. Then we also have these kind of brackets which we call the closed brackets. So when you have these type of brackets, this imply that the numbers that you have inside there, you can have a comma b. This implies that both a and b are not part of the set. We are only considering the numbers between a and b. It's just the same as writing an interval saying x is equal to a. Okay, let me write it this way. Yeah, so it's just the same as me writing something like this: x is less than, a is less than x, less than b. So this implies that a and b are not part of this solution set, but the numbers between a and b are part of the set. Okay, so this is the meaning of these brackets. So if I write something like 2, 5, I simply mean, as long as they are, on both 2 and 5, we have these kinds of brackets, the open brackets. This implies that 2 and 5 are not part of this set. Yeah, so the opposite is true for these brackets. So if we write something like 2, 5, if I write something like this using these square brackets, the ones that we call closed brackets. So if I write something like this, this means that 2 and 5 are part of this set. Yeah, so this bracket will show that the number that is right after the bracket is part of the set. So if I write 2, 5 like this, I simply mean that 2 is part of this set. But once I put this kind of a bracket on 5, it means that we're just talking about numbers from 2 up to the closest number that we can ever have to 5, meaning we're talking about numbers between 2 and 5, including 2 itself, but excluding 5. Okay, that's what it means. So in terms of intervals, this can be written as 2 less or equal to, because 2 is part of the set, so we say less or equal to x, which is less 5. Yeah, so if we're talking about x being the, yeah, okay, so yeah, being the domain, if at all we're dealing with functions. Okay, so I'm sure we know what these brackets mean. So let us quickly begin to solve the question. So if we say x is the universal set and it has 0 numbers from 0 up to 10. Yeah, so the other thing that I have to mention to you is that all interval sets are infinite sets. All interval sets are infinite sets, because when I say find me numbers that are between 2 and 5, no matter how good you are at mathematics, you can't manage to count these numbers, because we have 2.00000, a lot of zeros. You can write the zeros from here to Lusaka, and then you put a 1 at the end, and that is the first number. It's also between 2 and 5. You also have 2.0000000, you put a 1 or a 2 at the end. It's also part of this. So in other words, we're trying to say all we're trying to say whenever we're dealing with interval notations, we are simply talking about the set of what? Real numbers. And then remember, in our previous discussion, we said real numbers are simply just a combination of rational numbers and irrational numbers. So when you add rational numbers and irrational numbers, the resulting set is the one that we call the set of real numbers. So the set of real numbers is just the addition when you combine rational and irrational numbers. So rational numbers are numbers that can be expressed in the form a over b, meaning they can be expressed as fractions. Yeah, and as we discussed, we said rational numbers can either terminate or repeat. Yeah, so if you need a video concerning that, you can simply just inbox me on WhatsApp. I'll send you the link so that you can have time to watch. And then irrational numbers, you can't express this set of numbers in a fraction form. Yeah, so examples of these numbers are the root of 2, the root of 3, the root of 5. In other words, any root of a non-perfect square is an irrational number. And then apart from that, we also have pi. Pi is also an irrational number because it does neither terminate nor repeat. Yeah, okay. Let's quickly move on. So I was talking about the universal set here. So the universal set is from 0 to 10. Even if we have these kinds of brackets, as long as we're dealing with intervals, we consider that set to be an infinite set. Okay, so this is the universal set. Then we also have A. So A has been given to be 1, 4. Then there's also B, which has been given to be 2, 8. Then there's also C, which is given to be 3, 6. And now we've been asked to find B complement. Okay, so this is our B here. So the simplest way you can solve interval sets is by using the number line. Yeah, so that's the easiest way. Because if you are learning this for the first time and you want to be guessing, you get everything wrong. Yeah, so let me show you the simplest method that we are going to be using throughout. Okay, so we have been asked to find what? B complement. So I'm going to draw a real line here, and I'm going to put all the numbers that are on the in the given universal set. Sometimes you can not manage to put them on the real line, but you should just put in mind that whenever you're dealing with sets, if you've been given the universal set, you don't have to exceed or you don't have to cross the boundaries of the universal set when writing your answers. Yeah, in other words, you don't have to write anything that is not in the universal set. All right, so we have 0 there, we have 1, 2, we have 3, we have 4, 5, 6, 7, 8, 9, and 10. So now we've been asked to find what? B complement. So the first question is asking us to find B complement there. And we know to say our B is simply just a set containing numbers from okay, not really from, but between 2 and 8. Because 2 and 8 are not part of the set because of the brackets that are being used there. So on 2 there, I'm going to leave it open. Yeah, so this is an open bracket which is on 2, so I'm going to leave it like that. And then we have 8, it's also open at 8, so we are going to open at 8. Then we join the 2 circles. All right, so this set is open on both ends. So now if we talk about the complement of this set, we're simply talking about the numbers that are part of the universal set but outside the set B. So this is our set B. So now how do we write our B complement? So B complement is going to be there, and because it's open there, it means that for complement it's going to be shaded. Why am I shading for the complement? It's because I know to say 8 is not part of set B, meaning it's going to be part of the complement. So this will go up to where the universal set is ending. But look at the bracket that is being used on 10. It's a closed bracket, hence we have to close the circle there. Then apart from that, you can also look at 2. 2 is open in B, implying that it's not part of set B, meaning it's going to be part of the complement. Remember the definition of a complement. A complement of any set is simply just the list of the elements that are not in that particular set but present in the universal set. Yeah, the list of the list of elements that are not part of that given set. It can be set A, set B, set C. Yeah, so the list of elements that are not in set A but present in the universal set. Okay, so we shade there because 2 is not part of set B, meaning it's part of the complement. And then we also shade at 0 because of the bracket that is there. So we shade at 0 there. Okay, so this is my B complement. I also have another B complement there. So the next thing that we need to do here is to write the answer. So we have B complement is therefore going to be, so we note that it's shaded on 0 there, so we open the bracket, then we write our 0 there. When it's shaded, you open the square bracket. When it's open, you open the close, you open or close with the closed bracket. So we say comma. It's also shaded at 2. B complement is also shaded at what? At 2. So for complement, the symbol for complement, you can either use this symbol or that symbol. It still means the same. Okay. So it's also shaded at 2, so we close at 2. Then from there, we also have another set this side. So what are we going to do? We open another set of brackets. Of course, it's closed there. So at 8, it is closed. And then at 10, it's also what? Closed. So we close at 10. But we have 2 sets there. And how do we add 2 sets? How do you add sets? It's by using the union symbol. Yeah, so the addition of 2 sets is simply just union. Then the combination of 2 sets is simply just intersection. When you are combining, rather when you're finding the common elements in 2 sets, 2 or more sets, that's intersection. And then union is simply just adding 2 sets without repeating the common elements, right? Or writing the common elements once. Okay, so this is the solution for B complement. And how do we show this on the real line? If you want, you can show it in the same way that I've shown it here. It's still fine. Or if you want, you can omit this one. Or let me just draw it down. Or for the sake of time, let me just do this. If you want, you can omit this one and just write that. You just write the final solution. It's also correct. All right, so let's quickly move on to the next question. So the next question is asking us to find A intersection B. So A intersection, like I said, intersection is simply just the set of common elements between 2 given sets. All right, so A intersection B, what I'm going to do is I'll first have to put my A on the real line. So I'm using the real line to solve all these questions here, because I told you to say this is the simplest method you can ever have to solve sets. And then after getting used to this method, that's when you can be doing a bit of some inspection. You just inspect the questions and you know the answer. What I mean is that you'll be able to look at the question and know the answer even before solving anything, even before writing anything. So A is from 1 to 4. So A is closed on both ends. At 1 it's closed and at 4 it's closed. So we join the 2 and then we are finding the intersection between A and B. So let us also put B there. So B is open at 2 and open at 8. So it's open at 2. So this is my A. And then It's open at 2 and also open at 8. That is my B. So the intersection is simply just the common part here. So where these two lines are intersecting, this is what we are getting as our intersection set. So here, how do I write this in my solution or as my answer? So my A intersection B will therefore be equal to, when you look at this part here, or when you look at the first number that I have, there's a 2 here. But when you look at this 2 here, is it open is it open or closed? It's open. So if it's open, means that I'm also going to open when writing the answer there. And then when you look at the last number of what is common or of this shaded part, is it closed or open? It's closed, meaning I'm also going to write it the same way it is there. So it's at 4 and it's closed. So this is the solution. Writing this on the number line or on the real line, you simply just have to, let me just do this. So representing this on the real line, this is just 2, 4. So you write your 2, open at 2 and closed at 4. You even show to say this is A intersection B. This is how you show it on the real line. Alright, so let's quickly move on to the third question here. So we have A intersection B complement. So A intersection B complement is simply just the list of elements that are outside this A intersection B. So if you check, A intersection B is from what? It's from 2 to 4. Numbers between 2 and 4, but including 4 as well, because we have shaded at 4. And then from there we can now look at okay, so we are trying to find A intersection B complement. So if 4 is part of A intersection B, it means that it's not going to be part of the complement, meaning we open at 4 and then we are drawing this line up to where the universal set is ending. But because it's closed there on the universal set, meaning we also have to close this part. And because 2 is not part of A intersection B, it means that it's going to be part of the A intersection B complement, meaning we shade there. And then we draw the line up to where the universal set is ending. But because it's closed there, we also have to close this dot. Alright, so the solution to our answer here will therefore be, so from 0 to 2, and it's closed on both ends. So we have 0 to 2 closed on both ends. Then we say union, because I'm adding another set which I know that it's this side. Yeah, so we say union, and then is it closed or open here on the other side, because my A intersection B complement is simply just this one here. Okay, so we open there. So we open. So we have A intersection B, then we close there. Sorry, we look at what is, I don't know what I'm writing. Sorry for that. Okay, so we have an open bracket at 4, and then a closed bracket at 10 there. So this is the solution. How do you show this on the real line? Simple. The same way I showed you how to write it on the previous questions. That's the same way you do it. So you just say A intersection B complement. So this is the solution. There's nothing other than this. Yeah, so in some books they will not use these kinds of shading. Instead, where it is closed, they are going to do this. So if it's closed on 0, the way we have this question, they use that same bracket there. And it's also closed at 2, they'll use that bracket. These are simply just the same. So it's open at that. So if it's open at 4, then they'll use the open symbol, the open bracket symbol there. And then if it's closed at 10, they will use the closed bracket symbol. So this is what it means. There is nothing that is there's basically nothing that is different from what I wrote at first and what I've written. It's just the presentation of your work. Alright, so let's quickly move on to the next question. So the next question is asking us to find A intersection, then we have B minus C complement. So A intersection B minus C complement, how do you solve such a question? So first of all, what you need to understand is that this is mathematics. Sets are part of mathematics, meaning you have to follow Bodmer's. So Bodmer states that we have to start with what is in the brackets. So in the brackets we have B intersection C. So I'll first have to sort out what this is. Sorry, in the brackets we have B minus C. This is just the set difference. Okay, so we have B minus C complement. But remember, you have to know that if we have A minus B, this is just the same as A intersection B complement. If I have D minus C, this is just the same as D intersection C complement. If I have V minus E, this is just the same as V intersection E complement. This is what it means. Alright, so like this question here, this means we can write this as B intersection C complement. Then we close the brackets. Then we have a complement outside there. So using De Morgan's law, you also have to understand that. Using De Morgan's law, you also have to understand that if you have A intersection B and then in brackets complement, you can distribute this complement and have something which looks like this. You have A complement. We have distributed this complement on A. Then the sign here, the symbol there will change. Instead of intersection, it's going to be union. Then we say B complement. Same applies if you have C union B. Then you have okay, let me do this. You have D union B. You have D complement union B complement. This can also be written as D. You change the sign in between their intersection, then you write B, and then it's like we're just factoring out the complement. Alright, so let's quickly proceed. So let's apply this same De Morgan's law on this operation that we have here. So let us apply that. So this means that we can write this as B complement when we distribute the complement, but because this so the sign here will change first of all, and then because this C has already a complement there, it means that this complement and that complement will cancel, so just remain with what? C. So in other words, what we have here is or writing this statement in full, we'll have something like A intersection B complement union C. And remember one thing, sets, or rather, okay, so let me just put them in brackets. Okay, let me put them in brackets. I wanted to make a point here, but let me not confuse you. I'm going to say that when we reach what do you call this? Binary operations. Okay, so we have this, and on A, okay, we start with what is in the brackets, like I said. So let us find what B union C complement is, rather B complement union C. So B complement union C is therefore going to be equal to, so first of all we need to find what B complement is. And if you remember very well, we found our B complement. B complement, we found it to be, because B is here, B complement, we found B complement as from 0 to 2. Then we say union from 8 to what? To 10. This was our B complement. So now we're trying to find the union set between this B complement and C. So I'll do the same. I'll draw the number line. So my B complement is starting from where? From 0 up to what? Up to 2. So up to 2, and also from 8 to 10. So this is my B complement. Okay, then from there we also have what? We also need to put C on this same number line. So C is from 3 up to 6. So C is from 3 up to what? Up to 6. Okay, so C is from 3 up to 6. So we have it's shaded at 3 and it's open at 6. So this is 3, this is 6. Then we have, this is our B complement. So the union set between these two, because there is no common part here, there's no connection between sets. These sets means that will just it will just be we have 0, 2. Then we say union 8, 10. Union, our C here is 3, what? 6. Okay. So now, having found this, we now have to find the intersection set between A and what? And what we have found here, because we said this is equivalent to that. So let us find the common elements between what we have found here and A. So in other words, we're trying to find A intersection B minus C complement. So the intersection, I'm going to draw A here on this same number line, and then we're going to shade the common parts because we're trying to find the intersection. So A is from 1 to 4. So we have 1 there, and it's closed. Then we have 4 somewhere there, and it's also what? Closed. So we shade the common parts. So we have this part is common, then we also have this part being common. So the solution for this set is simply just, or for this operation is simply just from 1 closed at 1 closed at 2, because there is a closed bracket there and there. So we say closed at 1 closed at 2. Then we say union closed at 3 and closed at 4. So this is the solution to our question. And how do you show this on the real line? So this is the solution to our question. So if the question is asking you to, or if at all it has specified that you have to shade the region for, on the number line, then you have to write it the way I've been shading. I'm sure you've seen how I've been shading to find the solution, meaning you have to leave it that way. But if it just says leave or display your answer on the real line, you have to first find the answer, then you write your answer on the real line. Yeah, so meaning this is the solution that we're going to write here. If you want, you can shade, or you can use this kind of bracket, still the same. Then we shade at 1 and 2. Then we're also shading at 3 and 4. So this is our A intersection B minus C complement. Okay, let's quickly move on to the last part of the question. So the last part of the question says we find X, which is the universal set, minus A, then union A minus B. So like I said, if you have A minus B, this is just the same as A intersection B complement. So this means that we have X intersection A complement. But remember, the universal set intersection, the universal set intersection any set A, the answer is simply just that A. So universal set intersection B, the answer is B. So universal set intersection A complement, the answer will be what? A complement. So this part simplified further, this will give us what? A complement. Then we have union, and then here A minus B is just the same as A intersection B complement. So this is A intersection B complement. We have A intersection B complement. Alright, so we can use the distributive law to distribute this. So A complement union A. So I'm trying to simplify the set. Yeah, so we are going to have, in our first set, we're going to have, okay, let me show you what the distribution or the distributive law states. That's why I was saying I'm going to explain these terms when we reach binary operations. So, yeah, because normally interval sets are taught after binary operations. So, if you have A intersection B union C, what you do to distribute this, you have to get what you have there, A and intersection, you write it there. Or if you want, you can say, the simplest way to solve this, you can write two sets of brackets, and then here in each brackets, you are going to write what you have outside. So we write A intersection, then in between we write union there. Then you distribute, this B will come there, this C will come there, that's all. So that is how you distribute this. So in a similar way, we'll do the same here. So we have A complement, so I'm going to write my A complement there, then even union, I'll write it, then I'll open my brackets and close there. Then what is in between there is what I'm going to put there. Then I'll also write the same A complement union in the other brackets. I'm writing what is outside there. And of course, I'll write this A there and this B complement there. Okay. So we have distributed, but A complement union A, it's like getting everything that is outside A, you combine them with what? With A. So anything that is outside A combined with A gives you what? The universal set. In this case, we're using X to denote the universal set. So whatever that is outside A, when combined with what is inside A, you get the answer, which is the universal set. Okay, so here we have the universal set intersection, A complement union B complement. We can factor out the complement there so that it becomes A intersection B, and then the complement goes outside. But make sure that you change the sign here. Okay, but X, which is the universal set, intersection any set. Remember what I said? I said A intersection the universal set, the answer is what? Is A. B intersection the universal set, the answer is B. So this set here, intersection the universal set, the answer is what? That same set. Okay, so this is now what we have gotten as the simplified version of this question. Alright, so let us now find what the solution is for that. So first of all, we have to find what is in the brackets, because we have to follow the rule of body mass. Okay, we first have to find what is in the brackets there, then we find the complement of whatever that is in the brackets. So we first have to find A intersection B. Remember, we found A intersection B as we found A intersection B as 2, comma. If you remember very well from where we started, we found it here. This was the second question we solved. So A intersection B was 2, 4. Okay, so now to find the complement of this set, we are going to start from the universal set. Let me just draw this. So the universal set is from 0 up to what? Up to 10. And then our A intersection B is simply just from 2 to what? To 4. So it's open there and closed at 4. Meaning our complement will be everything that is remaining outside this part here. So the complement of this part, this is A intersection B. The complement of this part will be, okay, we have found A intersection B, which is what we wanted to find there. Now we are trying to find the solution of the whole question because of this complement, meaning the complement of this set is therefore going to be from, since it's open, meaning 2 is not part of A intersection B, meaning it's going to be part of the complement, meaning it's going, we have to shade there to show that 2 is part of the complement. Then we draw the line, and then when you look at X there, it's also shaded, it's also closed. Then we do the same this side. Since 4 is part of A intersection B, means that it's not going to be part of the complement, so we open there, then we close there because the universal set is closed at 10. So our A intersection B complement is therefore going to be equal to, from 0, it's closed at 0, up to 2, it's also closed there. Then we say union, it's open at 4, it's open at 4, and then closed at 10. So this is the solution for A intersection B complement, and we can write this on the set of on the real line as okay, we can write this as so we have, so you have to copy all the numbers. For me, I'm writing these numbers because of time. You have to make sure that you write all the numbers in between. Okay, so this will be closed there and also closed there. Then apart from that, it's open at 4 and closed at 10. So we have A intersection B complement. A intersection B complement. Alright, so I'm sure you people, you have understood this question. I don't know if you have questions. If you have questions, like I said, feel free to contact me on any of these lines on the screen. And then if you need tuitions or you need extra lessons in mathematics and physics, you can also simply just contact me on the same lines, and then I'll see how best I can help you. And then don't forget to subscribe to the channel in case I post any video. It will be to your advantage. Yeah, and make sure that you also click on the notification button so that every video that I'm going to be posting, you'll be notified that there's something that has come up on the channel. Alright, see you in the next tutorial video. My name is Hamted. Shalom, shalom.